Hello. Now we will be solving question number 32 from exercise 2 of laws of motion chapter. Phase 1. Let's read the question. A heavy particle hanging vertically from a point by a light inextensible string of length L started so as to make a complete revolution in a vertical plane. So motion is circular motion and that in the vertical plane. The sum of the tension at the ends of any diameter. So we have to calculate the summation of the tension at the end of any diameter, meaning you have to make a diameter and then you have to calculate tension at both ends and then you take the sum. Simple. So let me make a circle first. And I'm selecting a random diameter which making an angle theta from the vertical. So this is point A, this is point B. The A and the B are diametrically opposite points. So here the theta is again from the vertical down and here the same theta will be there from the. Let's say at point A, when the particle is at point A, the tension is T1. Obviously, the tension will be towards the center where the hinge is there. And at B, it will be again towards the center. So one is T1 and one is T2. So I have to calculate this T1 and then I have to calculate this T2 and they are asking about the value of T1 plus T2. That's what they are asking. Okay, so we have to solve at both ends. Now let's solve. So I'll bifurcate. Simultaneously, I'll be solving at both ends, A as well as B. Let me make the F query. At this point, speed is VA, and at this point, speed is VB. So at point A, force is mg downward. Here also at point B, force mg is downward only. At point A, tension is here, T1. At point B, tension is towards the center, which is down. Now, in case of A, the center is towards the same tension. So we need AC towards that point. So let's call it AC1. And here it is downward, AC. Let me make the equation here. So before that, this is theta. This is also theta. So let me make the component first. So this is mg cos theta. And here it will be again mg cos theta. In the first case, when the particle is at A, the one force is acting towards the A and second force is acting against A. So we'll get the equation as T1 minus mg cos theta is equals to m times of AC1. Or you can say T1 is mg cos theta plus m VA square by R. Similarly, when you calculate this, the AC is toward the center again. So here in this case, we'll get the equation as T2 plus mg cos theta equals to m BB square by R, and that will give me the T2 as BB square by R plus mg cos theta. I've got the T1 as well as T2. Now they are asking about T1 plus T2. Let me add both. So when I'll be adding, it will be negative. When I'll be adding this mg cos theta and this is minus mg cos theta, this will cancel out each other. So we'll be getting VA square by R plus m VB square by R. Or you can say m by R, you can take common, we'll have VA square plus VB square. So T1 plus T2 is m by R VA square plus BB square. Now, I don't know right now what's the relationship between the VA and the VB. To make the relationship between the VA and VB, I'll be using the energy equation. So I'll be applying the energy equation between A and B. So between A and B, there's no non-conservative force and there's no external agent between A and B. Since there is no non-conservative force and the external agent between A and B, I can always say the mechanical energy at A will be equals to mechanical energy at B. Now, I'm assuming this level gravitational potential energy to be zero. At level A, the gravitational potential energy I'm assuming to be zero. In this triangle, if you see, in this triangle, this angle is theta, so this angle is also theta. In this triangle, if you see, the hypotenuse is 2 times of r, and this is the height, which in this triangle will become the base. So this height between A and B will be equals to 2r cos theta in this triangle. Base by hypotenuse is cos theta. So at A, I'm assuming UA to be zero. So mechanical energy at A will be the kinetic energy at plus potential energy at A will be equals to EB, which is kinetic energy at B plus potential energy at B. Let the value half BA square plus 0 equals to half BB square plus GH, which is 2r cos theta. So VA square will be equals to VB square plus 2G into 2r cos theta. Now let's make it here. Let me replace the VB from here. If I replace the VB, I'll get T1 plus T2 is equals to M by R BA square plus. In place of VB, I can write BA square minus 4G R cos theta. That will give us M by R 2 VA square minus 4G R cos theta. Now, as you can see, the T1 plus T2 is depending upon the theta here. Theta, which is the angle with the word, meaning if I'm selecting the diameter at the bottommost point, the starting point of the diameter, if I'm selecting at the bottommost point, theta will be 0. If I'm selecting the diameter a little bit above from the bottommost point, theta will be more than 0. And this theta, if I'm only talking about diameter starting from the bottommost point, if I go for topmost point, ultimately the theta will vary from 0 to 180. And the thing is, when you are going from this point to this point, it's almost covering everything. So the variation of theta from the bottommost point, I can assume it to be 90, 0 to 90. Okay. So if from bottom, theta variation is more than 0 and less than 90. Or you can say from the bottom, if you're starting, theta is increasing. If you're increasing theta, the cos theta will decrease. If cos theta is decreasing, then minus of cos theta will increase. Which is coming here, minus. If minus of cos theta is increasing, then T1 plus T2 also increasing. Something especially what we have done. Negative. So that's the relation I'm getting. Now, after getting the relation, now let's check the options. Okay. the options. The first option is given, first increase, then in decrease. Yeah, that is possible if I'm varying the theta from the bottom till the top. So first half, the T1 plus T2 increases, and then again it will decrease because the theta will go from 90 to 180. The behavior from 90 to 180 will change. So that is a possible answer. Now, T1 plus T2 is constant. No, that's not the answer. It's not constant. First decrease, then increase. No. Decrease continuously. No. So answer A is the right answer in this case. So this question basically is quite nice question where we are making the relationship. Ultimately, what we are doing, whatever is given in the question, we are following the data. And from the physics point of view, we are applying the logic as well. The starting point of diameter, I'm starting from the bottom, theta variation. Okay. So how we are following these kind of questions, this is mix of theory, manipulation, and conceptual question. How we are getting the final answer with the manipulation, ultimately, that is a key in this question. Okay. So I hope you understood this question. It's a quite nice question. It covers multiple topics. It covers the energy as well. It covers FBD as well. And it covers basically tension as well. Thank you.